Hello everyone. Good morning, good afternoon, and good evening, people joining in from different parts of the world. I, Dr. Neha Tiwari, welcome you all as a host of ICICT 2022. Dear authors and invited guests, welcome to this technical session 2E. On behalf of Global Research Foundation, it's my great pleasure to welcome you to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you all are aware, we have been facing new normal situations while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances of post COVID-19 and making this conference more productive. Also, we wish everyone and their families a protected time. We hope you will enjoy 2 days of the knowledgeable and interactive digital sessions. Also, there is a special note for the presenters. You will be given 10 to 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder and I request while the presentation is going on, other participants kindly be muted. There is another request to all the participants that you all stay connected with us till the closing remarks. Just before we get started, I would like to introduce you all to the chair for this session, Professor Dharam Singh Jat. Professor Dharam Singh Jat received his degree Master of Engineering and PhD in Computer Science and Engineering from prestigious universities in India. He is a professor of computer science at Namibia University of Technology. He is the author of more than 150 peer-reviewed articles and the author or editor of more than 220 books. His interests span the areas of multimedia communications, wireless technologies, mobile communication systems, edge roof computing, and software-defined networks, network security, Internet of Things, to name a few. He has given several guest lectures and invited talks at various prestigious conferences. He has been the recipient of more than 19 prestigious awards, such as Eminent Scientist Award, Distinguished Academic Achievement, Eminent Engineering Personality, CSI Chapter Patron, CSI Significant Contribution, Best Faculty Researcher, Best Technical Staff, Outstanding University Service Award, and Distinguished ACM Speaker Award. We welcome you, sir, and thank you so much for chairing the session. Now I would like to start with the paper presentations with sir's consent. Sir, can we start with the presentations now?
Yeah, now we can start. Thank you, Dr. Neha.
All right. Thank you so much, sir. So with that, I invite the very first presenter, Yasmin Sheila Antille from Switzerland. I hope I took your name correctly, Yasmin. She's going to present a paper titled Designing a Driverless System Architecture. Over to you, Yasmin.
Thank you so much. Let me try and share my screen.
Yeah.
And I hope you can all see my screen now.
That's visible, very much.
Perfect. Then thank you for the introduction and good afternoon to everybody. My name is Yasmin Onti, and I'm very happy to be presenting the topic of our paper today, Designing a Driverless System Architecture. I worked on this project as part of my computer science bachelor's at the Zurich University of Applied Sciences with my supervisor, Dr. Monika Reif. The aim of this project was to design the framework of an autonomous system for a driverless Formula Student race car. This involves designing the hardware architecture for the driverless vehicle, involving multiple sensors which are used so the vehicle can operate without a driver's influence. In the following 10 minutes, I will first give you a quick introduction to the research field, and we will have a look at the motivation behind this project. I will begin by explaining what the Formula Student Competition is and why this project was set in that environment. Then I will discuss the requirements of systems engineering approach we took in order to obtain the engineering results that led us to a refined functional system architecture, which I will discuss in detail. The last segment of this presentation will include the conclusions of this project. Formula Student was brought to life in 1998 and since then offers a worldwide competitive design competition for student teams with the aim of building a race car. The different teams compete against each other during various events in several countries and in different disciplines. There are 3 different competition categories: the combustion engine vehicles, the electric vehicles, and the driverless vehicles, where the driverless category is the most recently added one, only being added in 2017. In 2019, the Formula Student team was founded at my university, and they began with designing and planning to build an electric race car. Then in 2020, a new driverless sub-team was formed with the aim of upgrading the electric race car to a driverless vehicle. With this upgraded vehicle, the team plans to participate and compete in competitions in the electric as well as the driverless categories. ETH's Zurich University team AMZ served as a big motivator and inspirator since they managed to break worldwide records with their first autonomous race car. It managed to accelerate from 0 to 100 kilometers per hour in only 1.9 seconds, which was faster than any road car and Formula One car back then. The process of developing the system architecture for the autonomous system took place in multiple stages. The other Formula Student team's approaches were first taken into consideration, and state-of-the-art autonomous vehicle architecture designs were studied and analyzed. The compliance necessary for the competitions and the construction rules and boundaries were carefully studied. Based on these gatherings, we constructed a use case diagram to illustrate the relationships between the use cases and actors. A novel approach to system architecture designing was used as groundwork for the functional system architecture model, based on which the software and hardware architecture was designed. As part of this project, all interfaces and hardware abstractions were outlined and can be used in the future as a guideline on how to integrate the hardware components into an electric race car. The results of the systems engineering stage were refined with the use of systems modeling languages. You might ask yourself where the requirements for this particular system come from. In the end, it was an accumulation of the rules and boundaries stated in the Formula Student Guidebook and the publications of other driverless Formula Student teams. However, not a lot of other teams have made valuable publications yet, as they also want to keep their system design secret in this competitive environment. The ETH team was the main source for general system information, as they've laid out the groundwork for many other teams, as well as for ours. This resulted in the requirements of which then the use case diagram and the activity diagrams were derived. Here you can see the use case diagram, which was based on the 21 functional requirements that we defined for the system. It contains 24 main use cases. However, due to time restrictions of this presentation, I will not go further into this, as I would much rather concentrate on the architecture design. The important part is to know that there are 2 main actors with the driverless vehicle, which is the human responsible for the system and the autonomous system itself. The authors, Mattei and Maurer, present a functional system architecture for an autonomous vehicle in the sense of a modular building block system, which you can see here. The system architecture here is developed in a top-down approach based on the definition of the functional requirements for an autonomous vehicle. In this case particular, it was an autonomous on-road motor vehicle, which follows the vision of an automated taxi. It explicitly combines perception-based and localization-based approaches. The operating of the autonomous vehicle in this case study is done on an intuitive level, meaning the vehicle follows instructions by mission input. This was used as the groundwork because in the Formula student environment, this is done in the exact same manner. The main structure of the system architecture is a 3-level design, which have assigned resolution levels as follows. I hope you can see my laser pointer. We have the strategical level, which is all the planning done for the driverless vehicle. The tactical level, which is all the decision making, and the operational level, which consists of all the reactive stabilization methods necessary. The modules developed and planned in the driverless student project are marked here in red. Based on this modular building block system, a more detailed overview of the assignments to the different abstraction levels was designed. And you can see the final functional system architecture here. Here we see the external data, which contains all data perceived outside the autonomous vehicle. For the integration of external data and later for the stabilization of the vehicle in its environment, the absolute global positioning localization of the vehicle is required. The simultaneous localization and mapping approach means that the autonomous system constantly maps and updates the environment, therefore quasi-continuously models the world. The perception columns contain all perception tasks related to the environment and the vehicle's self-perception. As part of the context and scene modeling, the autonomous systems tasks are to model the racetrack and the rest of the environment and to monitor the vehicle state and itself in the environment. The feature extraction and model-based filtering module extracts precise values from incoming sensor data, which you can see here. The environment sensors are external, while the vehicle sensors are internal hardware parts of the autonomous vehicle. The mission accomplishment column processes the defined missions. On a strategical level, the mission is chosen and the path is planned according to the mission requirements. The path planning offers the next navigation point as a guidance to where the vehicle must move, which is executed on the operational level by the trajectory calculation. The execution entails commanding the actuators and sending them the right actions. The decision unit handles the different racing modes, so the driving missions that I spoke of before. It sets the frame for what should be prioritized for each mission and checks that the autonomous system abides these settings. Further, it implements the state machine of the vehicle and makes sure the vehicle operates safely. Now, this was a very quick and very broad overview of the architecture model. And of course,
Yasmin, I interrupt. Yeah, just last 2 minutes are there. Please summarize your work quickly.
Yes. As I just quickly wanted to finish off, this was very quick and not very in-depth, but that's all that the time allows here. So I will just continue to the conclusions, which are that the overall idea was to provide a reliable and safe system in the driverless vehicle that takes into account different aspects of the autonomous driving process, such as the sensor fusion results and high precision driving algorithms. Software and hardware setup can be configured to allow for more redundancy. So the actuators and the sensors that you saw briefly in the architecture can be further improved by adding more sensors. And lastly, the suggested system architecture has a property of enabling easy modification and simple introduction of new functionalities into the system. This will also make it easier for enabling the further improvements. And that already brings us to the end. I'd like to thank you for your time and attention today, and I'm here for further questions.
Thank you so much, Yasmin. I'm so sorry because the time limit for the presentation is 10 to 12 minutes only. So we really want to give others also a fair amount of time for presentation. That's why we are just reminding you for the time. I request our session chair to please start with the Q&A section.
Thank you,
Professor.
Chair. Is there any questions from audience side?
No, sir, I don't think so.
Thank you, Yasmin, for your presentations. So, what is your contribution in this work?
With this paper, we contributed a novel way of designing, the novel system architecture for specifically race cars in the driverless vehicle world. So with this approach, we try to, define the modules necessary for the driverless vehicle.
In driverless car, there are two major problems. One is the heterogeneous connectivity, and other is the security issue. And your conclusion, you presented that the purpose of this project is to provide the secure driverless car. So I cannot see any security issues that you solved in your presentations. So how it is reliable?
The reliability is given in the modeling of the state machine. So while the state machine is here in the guidance unit is where the safety structure must be set, and while these safety regulations are then always monitored.
Okay, thank you, Yasmin, for your presentation. Thank you, Dr. Neha. You can call the next presenter.
Yeah, sure, sir. Thank you so much, Yasmin. I now invite Matthias Baumgart from Germany with his paper Requirements for a System Architecture for the Analysis of Scientific Texts. I request him to take over the mic.
Hello, thank you. Can I share my screen? Thank you.
That's visible. You can see it.
Yes, thank you. Hello, everyone. We are an interdisciplinary team of researchers in computer science and research management from Mittweida. And Mittweida is a small town in Germany, in the state of Saxony, with a university with around 7,000 students. Thank you very much for inviting us to the 7th International Congress on Informations and Communications Technology. And today we are blessed to present now our contribution, Requirements for a System Architecture for the Analysis of Scientific Texts. My presentation is structured as followed. At first, I talk about methods. Then we look at the concept and technologies. Then point 3 presents the derivation of a criteria catalog. And then I talk about the requirement clusters, and then I go to the results. The preparation of scientific research proposals and publications leads to a high workload for scientists, which has increased significantly in the recent years. At the same time, technologies in the fields of information retrieval, machine learning, segmentic technologies offers potentials to relieve scientists to increase the quality of scientific texts. Taking these technologies into account, this paper focused on the requirements for a generalistic system that allows the automated assessment of the text quality of scientific texts. Therefore, technologies, methods from the field of research management, information retrieval, machine learning were analyzed first. Then a criteria-based requirement analysis was performed, and as a result, 10 specific criteria were identified and enriched by quality-dependent criteria. These form the basis for the derivation of the total of 26 non-functional and qualitative requirements. There we analyzed dependencies, checked and transferred into a total of 4 requirement clusters. And this provides the basis for the creation of a system architecture that annotates, trains and evaluates texts and contributes to the assessment of the text quality of scientific texts. Since there is no tool for the analysis and evaluation of scientific texts, especially of research proposals, which provides the user for assessment of text quality, the authors proposed a system that can do this and thus reduce the effort of scientists. The system incorporates state-of-the-art technologies. They are in the area of data preparation, e.g. lemmatization, stemming, name entity recognition, or word embedding. Furthermore, current methods of text classification are considered, which are particularly important in the area of future extraction and selection. The combination of technologies and methods of information retrieval, machine learning, and applications from the field of text analysis, especially German tools, lead to the creation of a new software or framework with a view to a concrete application. In information retrieval, the most relevant documents for queries should always be identified, even if the queries are characterized by a high uncertainty factors. Technically, this is done by preparing input data and considering it to a description. Machine learning offers a possibility to extract structured information from unstructured text by recognizing patterns and regularities, especially lexical features, syntactical structures, statistical observations, and machine learning techniques are used to find specific patterns, structures, and relationships into the input text, thus extracting deeper semantics relationships. The context pays attention to unsupervised learning methods, e.g. in the document data clustering, topic modeling, or the creation of vector-based word and language models, as well as the supervised learning methods, which are used, for example, in text and document data classification or target information extraction. The derivation of the criteria catalog is based on the practical analyzing of a research proposal data set from our university with around 50 proposals in the fields of engineering, laser technologies, and informatics. And the first criterion, processing on multimodal data, leads to the requirement of processing of text and image data and tables, and the use of individual text tools. The second criterion, data organizations, leads to the requirements of the management of text and image data and tables, and the management of multiple text tools. The criterion, processing of metadata, leads to the requirement processing metadata from reference data and processing of metadata from other systems and feature extraction. Feature extraction is required, especially when machine learning is used. The criterion processing and parameterization of meta-process change leads to the requirements parameterization of flexible process change. And the criterion data exchange leads to the requirements integration of standardized file and data exchange formats. There's the definition of import-export interfaces and integration and linkability. Data acquisition and manipulation, resource efficiency, integration of technologies, and interactive and local dependencies are more criteria. Based on these 26 requirements for the overall system, the system was divided into 4 requirement clusters. As a description of the 3 technical concepts, as well as 1 quality-related concept followed, whereby only the technical concepts are presented here. As the first data handling requirement is the core system. The database system is the central component, which consists of the database and the database management system, which forms the control unit for access to the data. The database itself contains document data from the use cases, document data from external systems, but also terminological data. Another important requirement that the database system as a whole must fulfill is a high degree of adaptability, which is based in particular in the different tools, their interaction, and the different data corpora. The database management system as a central control unit, import and export layers in addition to the rule for defining and organization of data. The process of collecting and extracting relevant metadata is supported on the system side by the metadata aggregator component as part of the data handling concept. The core function of collecting metadata is performed by the metadata collector, which holds on configurations about relevant data. The metadata aggregator component provides files and aggregated metadata to the database management system via import layers. Overall, the data handling concept aims at systematically structured and long-term available and consist a collection of document and process data to which secure access to provide via import-export interfaces. The second concept, text analysis requirements, aims at the use of state-of-the-art technologies for the assessment of text quality in general. The acquisition of data necessary prior to the use of text analysis techniques is done by equipping the system with relevant base corpora, which is suitable for training models, importing the use case specific data corpora, and importing metadata. Additional data is obtained by processing data as part of the approach to text analysis. Primarily, this is done by processing documents and metadata via the API, which provides machine-readable data to the toolchain component and also returns it to the database management system after it had been processed. Second, the processing of documents and metadata takes place via the user interface, which makes user data and information available to the database systems via the annotation component. The API acts as an application interface in the context of the concepts for the text analysis. On the one hand, communications with the database takes place via the import-export interface, and on the other hand, this handles communications with all applications via the toolchain component. The toolchain component contains and controls the individual text tools. It accesses pre-processed data and makes final proceeds data available for the post-processing. For this workflow, files and metadata from the database.
Just a reminder for last 2 minutes. Yeah.
Okay. For this workflows, files and metadata from the database system were accessed via the import interface controlled by the API. And after processing, they were saved back via the export interface. Furthermore, the processing of metadata from reference data is done by the toolchain. For this, for example, data resulting from the application sequence and function of the tools used or metadata that is generated during the processing of the documents. These are collected and stored in an XML file. The third concept aims the assessment of text quality in the field of scientific tests and combined different technologies. But now I will come to the results of the general concept. All in all, criteria-based requirements analysis was performed. we generated 10 specific criteria and enriched by quality-dependent criteria. These performed the basis for the derivation of the total of 26 functional and non-functional qualitative requirements. These were analyzed, checked for interdependencies, and transferred into a total of 4 requirement clusters. And now a basis for the creation of system architecture was created, which annotates, trains, and evaluates text and contributes to the evaluation of text quality of scientific text. This concludes my presentation, and if you are interested in the system or in exchange, you can contact me via these contact details. Finally, I would thank the organizers of the 7th International Congress on Information and Communication Technologies 2022.
Professor Singh for the queries section. Any queries, or I also request participants, the other participants, to come up with the questions if you have on your mind, so we can make this session more interactive, more knowledge sharing one. I doubt if Professor Singh is.
Sorry. I was talking to myself.
Yeah, you just
thank you.
Unmute yourself.
Thank you, Yasmin, for your presentation.
No, sir. The second one was he was Matthias.
Yeah.
Matthias was, yeah, he just finished his presentation.
Matthias, yeah. So Matthias, my question is related to your topics. Why your requirement is for only the scientific test, not it's for the other text. So what is the difference between the scientific text and other text in your requirement?
Sorry, I didn't understand the question. Why I use only text?
In the topic, this requirement is especially for the scientific text.
Yes.
So what is the difference between the scientific text and the other text that you consider in your requirement?
Every text in scientific text, I mean research proposals, and research proposals are characterized by different writing styles. In our data set, we have text from laser technologies, we have text from engineering, from informatics, and in every scientist discipline, the texts are very different. And the first step is to extract relevant features which have to be combined to reach a good assurance.
So you have done the qualitative study for the requirement, is that right?
Yes.
It's a qualitative as well as quantitative.
I have the quality.
Yeah, in your requirement, you have done the qualitative study as well as the quantitative study. You know, the research methods there is a qualitative method and the quantitative method. So, okay, in the quantitative method, you recommended that you have used the statistical method as well as the machine learning algorithm.
Yes.
So, which one is the best, statistical or the machine learning for the scientific text?
Both. Both. Statistical method focused on accounting words, accounting key phrases, keywords. Statistical and machine learning algorithms will focus on decision trees and yeah, also state of the art methods and algorithm. And in this project,
okay.
yeah.
Okay, Matthias. So can we replace the statistical method with machine learning? Because everything is available in the machine learning.
Why machine learning?
No, because is there any necessities that we use the statistical method? Can we replace the machine learning with the statistical method?
I'm not sure.
We can. Okay, thank you. Because we can remove the outliner, and there are so many outliners in the statistical method. That's why we are using machine learning. So thank you for a nice presentation. Dr. Nia, next presentation.
Thank you.
Yes, sir. So I now call Nikolay Stominov for his next presentation. For his presentation as the next paper presenter, he is going to talk about restitution coefficient determination of 3D printed materials. You
Yes,
can start
thank
with
you.
your presentation. Yeah.
Yes, we can just share the screen. I would like to thank you for the invitation, and I do hope next time to see you in London or whatever is the conference. As the
Hopefully.
colleague said,
Yeah.
restitution coefficient determination of 3D printed materials. We are from the Institute of Information and Communication Technologies of the Bulgarian Academy of Sciences. I'm the one co-author. The other one is my colleague Stanislav Gyoshev. This coefficient of restitution is needed for 3D software simulations in ball mills. So this is a little introduction about the grinding process. The grinding of different materials is a very important industrial process. In that specific process, the material is crushed or milled, depending on the determined size that we want to be as output material. And also, it's very important to investigate the interactions between the grinding bodies, the grinding media also inside those ball mills, and the interactions between the material itself. The paper aims to investigate the coefficient of restitution of 3D printed materials by using the drop test method, which is the most advanced method and the easiest one actually. The alternate results are described in a table and graphic presentations. This is the experimental setup. As you can see, we are dropping milling a material for it represents a ball. It represents a sphere that needs to mill the materials. It's dropped from a certain height, and we are determining the coefficient of the restitution. For this thing, we are using the high-speed camera, not memory cam. Actually, this is a very slow process for this camera because it can capture images with what high-speed processes. For the next step, after we determine these coefficients of restitution, for the software implementation, we need to include this data, which is the volume of the different materials, the mass, and also the density. The tested materials were PLA, PETG, steel-like, carbon, and very white. All the materials except the last one are from FDM printers. Unfortunately, we couldn't find that data in the publication, so we needed to measure it. This is actually the data from the experiments of the different materials. Also, the spheres are tested on different plates. You can see the plate here, and this is the plates, and these are the spheres. We're using this, as I told you, to investigate them and to use them in 3D software. This is graph of the coefficient of the restitution of used materials, the differences between them. This is actually the future steps when we determine these coefficients of restitutions. We will use them also the same materials in that laboratory ball mill. Again, aiming to investigate the process of the milling, defining the angle of separation, defining the angle of falling, and also the interaction between the different materials. The purpose here is to investigate the different size and different shape as the milling material also, and the not milling material, the milling spheres and the milling environment inside, so-called lifters. And we hope to have the same results as the real experiments in that mill to be verified with the 3D software used for the same milling. It's called LM software. We use it a lot. And last but not least, maybe the most important, the main aim is to, with different sizes and different mill environment, to reduce the RPMs of the mills so it can be more energy efficiency. These 3D printed materials, the coefficient actually, and the result shows that they are elastic plastic in nature, but some of them, such as PLA and PTG and flex materials, are more elastic than the other materials like steel filament and plexiglass. This can be seen mostly from the experiments performed with steel spheres, which has a much higher modulus of elasticity than the other materials. The idea here is that the flex material is actually very flex, and it's something like the real used, of course, not the same, but similar to the real used materials in the ball mills. This research was carried out by one of our projects from the institute, funded by National Science Fund. And thank you for the attention.
Thanks a lot, Nicole. I really appreciate you to sum it up in time. So that was presented well on time. So you concluded it timely. So big thanks to you for that. So the forum is now open for discussions. Professor Singh.
Thank you, Dr. Tiwari. Thank you, Nicole, for your presentations. So in terms of, because this is the 3D printing technology is the future technology or latest technology. And it's good that you are doing something for restoration or something. So what methods you used and which methodology you used for your analysis part or coefficient determination?
Sorry, I couldn't hear the
Coefficient
question.
determination
Can
is
you
very, very
speak a
important.
little louder? Or just type the question, because I can't hear you clear.
Okay, the coefficient determination is very, very important in 3D printing.
Yes.
So what parameters you considered for the coefficient determination, and what algorithm you used in your determination? Am I audible now?
Can you write me
Yes,
the
sir.
question? So,
Absolutely, sir.
we're using in the software we use, it's very important to set the exact parameters for the simulations, and we aim at to use the 3D printed materials because they are easy to set up the simulation. I mean, to verify. The idea is after we set up the same simulation with the materials and the interactions and the movement of all the bodies, the idea is when all is set and it's the same, to make it bigger, because these mills actually are 5 meters diameter. So the idea is to use that printed materials just to investigate the movement and interactions. And the printed materials are used with the FDM printers, as I told you, with the specific temperature properties. All the printed materials are full fillet
So Nicole, which software you use for your simulation work?
Excuse me?
What is the name of software that you use for your study?
The software is called Adam software. It works
Okay.
on
It's
the
open
discrete
source, it's
element
paid
matrix.
software.
Sorry?
It's open source, it's paid software.
No, it's not open source, unfortunately. We bought it from one company, that software, for academic purposes. And it's widely used for industrial processes such as milling, crushing, and so on. Now, actually, we are
Okay,
using
thank
it
you.
in...
Thank you, Nicole, for presentation.
Thank you.
Dr. Nia, you can
Thank you,
continue
sir.
now.
Yeah. So up next we have Paula Urs. I hope I pronounce your name correctly. She's from Portugal and her paper title is Social Studies of the Future, a brief outlook about their contributions for ICT areas. I request you to start with your presentation. The stage is all yours. Kindly unmute yourself, Paula Urs, and start with your presentation.
I'm here. I'm here. I'm trying to
Yeah,
share the. Just a minute.
yeah, no issues.
I used to share, but now,
Screen share.
yes, but sorry,
Yeah,
I don't know what happens. So,
that's absolutely okay. Take a deep breath and start.
yes. So, our paper is entitled, as you mentioned, Social Studies of the Future, a brief outlook about their contribution for ICT areas. My name is Paula Urs, as you mentioned. I'm from Nova School of Science and Technology from Lisbon. This paper has been done by me and my colleagues from the University of Minho, that is in the north of Portugal. So, I'm going to context the purpose of the paper. So this article clarify what is meant by social studies of the future and shows the kind of contribution that can make to the science and technology. So what we want to seek is to demonstrate that it's important to create bridges between the various disciplines in order to promote knowledge that helps society to deal with the future. So we will underscore the relevance of interchanging knowledge through interdisciplinarity, that is one of our important concepts, as a strategy of governing the science and technology of the future. So with this purpose, we are focused on the social studies of the future. And of course, we want on this topic, we want to emphasize the need to consider the centrality of future in decision-making process concerning science and technology. So it means that our purpose is to emphasize the need to look to the future, considering the evolution and the development of in terms of science and technology. So in terms of only to illustrate, during 2021, the journal Future has published different articles on the topic, but the most cited cover 3 interconnected themes. So, as you can see, 4 of them were the future of digital society, the debate on quality of life and alternatives to grow, the importance of technology and digital transformation narratives. So, taking into consideration this journal, we also analyzed that the main line of analysis encompasses by the social studies of science was centered um, on artificial intelligence, big data, and the regulation of the use of innovation. This topic is related with big data and artificial intelligence, gather increasing importance within the social studies of the future due to the impacts they represent for companies and the economy in general, as well as for the social relations and social organization. Another very important topic is disasters, resources, and style life changes. The studies here analyzed diverse problems from changes in eating patterns to development of new products originated from genetic modifications oriented to prevent the lack of food in several parts of the globe. Another one, as you can observe, work patterns, lifestyles, and organizations, a topic of growing interesting has been the transformation of the concepts and valorization of working time associated with the digitalization and the modification of the relationships patterns between workers and organization. And COVID science and technology in this context of the debates on the pandemic and the measures adopted, the analysis constructed some central issues for understanding the relationship between social sciences and ICT from a practical and operational point of view. And the last, future-oriented policy and strategy. In 2021, publications are in line with the seminal idea in sociological studies on science and technology, the need for planning and inclusion study of long-term view in administration and decision-making and regulation. As you can observe, these are the main topics that we're considering the social studies of the future, lessons that live. Scientists from different fields need to specify the expected impacts of research, the ethical issues involved by discriminating the social inclusive potential of research, as you can observe in our picture. Social studies of future tend to emphasize the need for research and development programs in science and technology to observe participatory principle. It needs that we need to involve population. We need to have a very participative way of decision making. In addition to the relevance of participation, the studies of the future give importance to the communication methodology of the future, inquiring the way in which politicians and scientists convey certain ideas and images that show either extremely pessimist or extremely optimist threats of that future. The discussion of the future is as a main topic of research with contributions into ICT demands to overcome long-standing separations between science areas and embrace interdisciplinarity. To conclude, because we don't have a long time, social studies of science and technology have proven long time ago that society cannot be a mere consequence of socio-technical development, but there is a need to adjust all these achievements in a consistent way with the human existence on the planet. It means that it is more and more important to interconnect and to combine both things. We showed that some of the late improvements pose very questions to ICT, especially when addressing the effects of the consequences in long term brought about digitalization. The discussion needs further analysis, but it became clear that there is a new urgent need for dialogue and communication in different areas of research that can provide better and wider knowledge on the ways to anticipate and study the future. Thank you.
Thanks so much, Paula. That's wonderful to know that your paper is addressing something related with social cause. So
Yes,
that was an interesting one. Thanks a lot for sharing it with us. Can
as
I
you can,
ask other
as you,
participants? Pleasure is all ours, Paula. So can I
sorry,
ask others to come up with the queries if you have any questions to ask?
we are from social science, so we will introduce a new dimension in this discussion, perhaps.
We can understand that's a kind of new learning for us as well because targeting
I'm a,
only on
I'm a social scientist, but I teach. I give lessons in the faculty, in the large faculty in Lisbon. That is
Mhm.
a faculty of engineers. So we have a department of
Interesting.
social sciences, and this dimension is very important. Why we think that will be a great to bring that perspective to here.
Interesting to know that, Paula. Thank you. Over to you, Professor Singh.
Thank you, Chair. Thank you, Paula, for your nice presentations and regarding the social issues that you highlighted. So, you know, these days, social science plus ICT we called SCI, human computer interaction. And, and every social scientist, they are moving towards the SCI right now. So it's the same thing that you already in your conclusion or in concluded that we have to take care of these issues. But we have already we have a stream of SCI and they are working since long time now. There is a separate branches in the computer science as well as in the social science.
Do you
So
want?
yeah.
Okay. Please.
So is there any something you want to introduce something in SCI or is there any
No,
deficiency or yeah.
what I can underline, and probably you know as well as me or better than me, that nowadays and increasingly social science could be we can when we speak about interdisciplinarity, we can speak about small interdisciplinarity or big interdisciplinarity. It means that in this field, if I work with computer science engineers, for instance, I'm speaking about big interdisciplinarity. And nowadays, this cross of combining different knowledge to cope with complex problems that we are facing in society is increasingly more important. So we believe that we have to more and more give strongness to the way of having projects and publications and the discussions crossing different disciplines and taking into account, for instance, when we are developing systems and infrastructures and the computational architectures, to take into account that they are going to interface with the humans. So it is one of the topics with the big data. But as you observed in my presentation, I try to cover different topics, but of course that all of them, it deserves to go deeper and to analyze the way that we can combine the different knowledge to have the better results in science.
Thank you, Paula, for your presentations. Because why I'm interested, my wife is also the professor in social science in one of the university here. So thank you your presentation, and we'll discuss more in detail later. Thank you, Dr. Nia.
Thank you for the opportunity also.
So that's just a mere coincidence. We have the next paper related with socio-technological analysis. So I now call upon Miroslav Kis from Canada. He's going to present his paper on the title A Socio-Technological Analysis of the Use of Blockchain in Financial Systems. So, Mr.
Okay.
Miroslav, can we have your presentation, please?
Yeah. Okay. It was sending me some strange messages that I have to prove something. Okay. Actually, I have to say that basically I couldn't have a better introduction than the previous analysis that was presented. And also second part is this morning we were talking about disruptive technologies, and blockchain and cryptocurrencies are definitely something that is disruptive at this moment. And a lot of stories are there, but what is missing and what I'm going to try to explain in this 10 minutes or so, that that analysis from both technology side and human side, human aspects, is absolutely necessary to understand what really this fascinating technology can do. So let's start with that. So first of all, what is blockchain? Promise of blockchain is that two parties that do not trust each other can transact directly in a secure manner. So basically that means that we can do direct transaction. You don't need intermediaries. This is a trusted public ledger. So basically whatever transactions we do is going to be publicly available. So it's going to be known, and we cannot really fake anything, pay twice, same transaction for same money, and so on and so on. So also promises that a cost efficient system. So what they're saying, central financial institutions like banks are charging and overcharging. They're not even secure enough. And then they're saying blockchain is going to solve that problem. Also, their claim is that security and resiliency of the system is excellent, and user privacy is guaranteed. So let's take a look at all these elements and see what exactly we have in real life as opposed to just promises. So first of all, question whether we have intermediaries. This is fascinating technology, solutions, advanced cryptography, rule-based systems that are smart contracts. Smart contracts are something that we put in code, and then it's executed if certain conditions are met. And basically I can send money to somebody if I get something in return. For example, very simplified, very simple example. So, but and it says, okay, there is no intermediaries. However, that's not necessarily true. Blockchain is developed, operated, and used by humans. So basically, we cannot really say that there are no intermediaries. There are different intermediaries. Then when we send those transactions over the internet, basically, there are miners, so-called human miners, that validate and approve those transactions. So obviously they are humans, they are involved in that whole system. So we cannot say there are no intermediaries, there are no banks necessarily, but basically there are intermediaries who are still looking at what we are doing. Next thing, it's very simple explanation on how system works. They assume that intermediaries, those miners, are rational, so they want to increase their individual wealth and have sufficient knowledge to assess those transactions. We'll see that's not necessarily always the case. Finally, what they say, you can have hundreds, thousands of those miners that are joining that blockchain. And they say majority of miners will come up with the right decision, and they are going to say, okay, Miroslav wanted to send to Dr. Nihat Tiwari 10 bitcoins, but basically that's fine. He has enough money and everything is correct. Whether that's the case or not, that's a different story. So let me go briefly through the elements of this, how that works, blockchain. First, we initiate a transaction and data is recorded and digitally signed by private key. So basically you have digital signature there, and when I'm sending money to somebody, that transaction is going to be signed. My private key cannot be forged. I cannot later say that that was not me. However, privacy is there de facto because I have private key. Nobody knows who I am, but this based on my pattern of transactions, somebody can figure out if I'm sending billions of dollars, probably I'm Elon Musk, not Miroslav Kish. Then next step is that once when I finish that transaction, I post it and send it to those miners. And they are validating that message and they're checking whether that message is fine, whether I'm trying to use maybe the same money before I used, and they are going to say, okay, this is fine, or that's not necessarily okay. He tried to do that before. So let's see. Then validation process. This is a key piece where we need social studies to understand. First of all, these miners are anonymous people, not accountable to anybody. We don't know whether they have any knowledge of finance or something. So they might, majority of them can decide that water is not wet. I would joke about that. So basically that's not necessarily the case. So blockchain assumption that these people are knowledgeable is not necessarily correct. Then we have a phenomenon that is known as in behavior economics as satisficing. When you have to do something, you do with the least effort that you have to put there. And then these people are going to look at those transactions. They are awarded, by the way, if they are the one who first approved transaction, they are going to get some money from blockchain, and then they are going to rush and say, okay, let me see, okay, this transaction might not be bad, let me do it and approve it or disapprove it, whatever, but let me place, roll the dice and maybe be the first to approve it and get reward. Also, when they look at those miners, typically technology people are looking at this and say, okay, basically they have that motive to gain more money, but you might have people that are not at all interested in immediate reward. For example, they might be criminals that want to crash the system, political motives, and so on and so on. So this is a problematic piece where we have to be careful when we are talking about blockchain and big cryptocurrencies. Then statistical independence and herd behavior. People might tend to, this whole model about blockchain comes from reliability theory. They don't have time to talk about that. Byzantine generals model. And they assume that there is a statistical independence of every decision that every miner does. However, humans are not servers. They tend to follow the leader, and that's known in behavioral economics as herd behavior. At the end, log and complete, basically transaction is now, let's say, approved by 51% of these miners, and then they put it in a blockchain. And this is something that is pretty good because basically that blockchain can be shared with all these miners, and then it's a resilient system really, because basically there is no single point of failure. And this is one of the advantages of these new technologies. Quickly
Just
to
a reminder to you, sir, we only have last 2 minutes with us
fantastic,
for
thank you.
this
And
presentation. Yeah.
exactly, I need 2 minutes only. Last slide. Processing speed, it's quite slow, because basically all these communication among these miners might be take quite a bit of time, and you might wait for 45 minutes or so until your transaction is approved. And if you want to buy a coffee, then your coffee can get cold until your payment goes through. Processing fees, they promised initially that it's going to be low, because basically there are no big bad financial institutions that are charging. Turns out that right now, if you want to do one transaction on one of the famous Ethereum blockchains, it can cost you $70 to $100 for one transaction fee alone. So basically, these are the some things that we have to have in mind. Is really fascinating technology. I'm quite sure that it's going to have impact on the rest of the financial system. However, we have to be careful when we are applying that, understanding what exactly we are getting. It's not that simple. That would be all. Hello?
Yes, sir. Is it over now?
Yeah, it is. Sorry, I'm trying to
Stop
figure
the screen
out.
share.
Yes.
Yes, that's done. So your thoughts were very well fabricated, I would say. And one more interesting thing is that we have 6 paper presentations in all and 15 participants. So like double the number of presentations that we have. So it's quite a good number. So I request Professor Singh to start with the question answer session.
Thank you, Dr. Morislav, for the presentation for the latest technology, blockchain technology. So you know the blockchain technology is the emerging technology, and we are using it in the various sectors. And this is the case study of the financial system. Hello.
Yeah, who is this?
Yes, so your paper is still remaining.
Yes.
We'll
What
call
is
your
it?
name. Kindly mute yourself. I request Juliana to.
They what?
Riddhi, will you please mute him?
So,
Thank you.
Dr. Neha, can
Yes.
we conclude the session now?
So just one more presentation is remaining.
Okay.
He's the one who was about to, yeah, that's the last presentation for today. So I would like to, so I would like to invite, I think he's busy over a call, sir. So even then, I'll just give it a try. I'll call up the name. So yeah, I think he has, hang on. So Askil Uzor Okeke, I think I pronounced it correctly. I request you to start with the presentation on paper measuring e-government systems user satisfaction using a multi-criteria analysis model, a case study of Botswana.
Okay, just give me a minute to.
Yeah, sure.
So I just give an introduction and the problem, and then the objectives, and then how we conducted the study on measuring e-government systems users satisfaction using a multi-criteria analysis model, MUSA, and we are using our case study from Botswana. I just start with the concept of measurement. In measurement, we assign identifiers to attributes of entities of interest in order to be able to describe such entities as they are in the real world. And we see measurement in various aspects of life, such as in trying to determine economic indicators, diagnosing diseases, and in weather forecasting. And in software systems also, we have used rigorous measures to be able to determine the quality of the software systems, such as the lines of code metric, the Maccabi cyclometric complexity, the HASTI software science measures, maintainability index measures, and so on and so forth. So, but here we are trying to apply metric in the measurement of the satisfaction of users of e-government systems by applying a multivariate method. There are other methods that can be used or that has been used, such as discriminant analysis. But in this method, we are looking specifically at the multi-criteria satisfaction analysis model. We have used this model to measure the satisfaction of users of Botswana's e-government system. We are from the university and we try to do things to compensate for the services to community by trying to engage in various areas of community service where we can. The problem here is that concerning the model MUSA, most studies have said that it's a good model and it's rigorous enough for measuring aspects of software, such as the satisfaction of users of some services or software services. But one particular study said that MUSA model does not always give an interpretable result. So we try to check whether from our own study, whether we do get interpretable result from the application of MUSA model, the multi-criteria analysis model in the measurement of users' satisfaction of this e-government system. But most essentially, in the African context, most countries have deployed e-government systems, but it is not very clear if the systems have been appropriately evaluated using rigorous models. So those are the two things we set out to do in this study. So our objective will be first to verify the multi-criteria satisfaction analysis model as an interpretable, rigorous, and reliable satisfaction measurement tool, and then to use the same tool to evaluate the user satisfaction of Botswana's e-government system. We looked at previous studies that use the multi-criteria analysis approach MUSA, such as the one done by Arabatis and Grogodis in 2010, that used the method to find a gap analysis in order to investigate visitor satisfaction and perceptions towards a service provided by a system. The other study was also done by Gregoris and his colleague. It's called Telos. Telos was a computer software that was used to evaluate customer satisfaction, and then how it was also used to compute this MUSA model. And another one was the Ypsilandis et al. 2008, which applied the MUSA model in an education program. The goal was to be able to find a satisfaction pattern of the participants. There was a project manager and he had three categories of stakeholders. He wanted to know from each of the group of stakeholders what their satisfactions were for using those systems. But from all the three that we examined, all the studies reviewed did not concern e-government systems, and there is no rigorous nature or usefulness of this multi-criteria analysis model that was measured in their studies. So in our own study, we try to combine the two to show that MUSA is rigorous enough, and then to show that it can yield interpretable results from our studies. It was a quantitative research, so we we have questionnaires distributed to about 170 purposely selected participants. Out of the 170, 136 returned the questionnaires. And then because it was a purposive sample, 101 of those 136 were actually non-IT users, but the other one, non-IT professionals, but the rest of them, about 36 or 35 of them were actually those who are IT professionals. So because of the nature of the evaluation, we mixed the non-IT professionals purposefully selected with the IT professionals. And then the questionnaire used a 5-point Likert scale from strongly agree, strongly disagree to strongly agree.
Sorry to interrupt. So we are running short of time. So could you please conclude the presentation?
Let me go to the results. The dimensions we looked were the functionality, usability, reliability, maintainability, and we took these from the ISO IEC 9126 model. We justified the use of the sample that 136 was good enough from previous studies by using the Cronbach alpha table. And then our result shows us where this was a Motorola satisfaction model procedure, which we also followed. But this is the model itself and how it works. And then I just go to the conclusion and the results. The Musa model was appropriate in evaluating the systems. Botswana e-government system has a global satisfaction index of 86%, a partial satisfaction index of 54.5%, and a demand index of 38.5%. The partial satisfaction index measurement for the individual components of actual use, usability, functionality, reliability, maintainability, portability are indicated. So those components with low partial evaluations indicate that those are the areas that need attention. The areas that have very good evaluation are the areas that at least they know that they have done well. So the results indicate that the users were also non-demanding users and that the Musa model was appropriate in measuring the systems and it yields interpretable results. And then we made some recommendations for government for the need for public sensitization of the e-government systems and then the benefits so that there could be more participants. And then the need for investment in training the staff of the various government departments for them to be able to manage e-government systems and the need for them to explore also alternative digital development, inclusive technologies in the areas of mobile telephonies, and then the need to regularly evaluate the systems. Right now, we did government to citizens. There is need for future of evaluating the system based on government to business, and then with a larger number of samples. And these are the ministries and the e-government systems that were involved. And then the various linear, we applied also linear programming, and then how we computed the results are shown in the various things. Thank you.
Thank you so much. Any queries from anyone? Professor Singh.
Thank you, Dr. Neha. Thank you, Dr. Oki, for your presentations, nice presentations in relation to the e-governance. And it's very, very important to develop the policies or some other things. So, Dr. Oki, is this study, is the qualitative study or quantitative study?
It's quantitative.
Okay, quantitative. I think you have selected 171 samples and received 136.
Responded fully, yes.
Okay. Did you change the questionnaire or use the same standard questionnaire?
We did a pilot. We initially did a pilot with.
Okay. So that is not standard, and that is applicable. So you modified something in the standard questionnaire, then that questionnaire is appropriate for the Botswana. That is your conclusion.
Back
Right.
to know how to focus, we made some few changes on the questionnaire.
Okay, okay, good. So you already told that this is applicable for the African countries, that's right?
Yeah, because the model, the multi-criteria analysis model is rigorous enough. It can be applied by anyone. The model is there, is in the open. Anybody can study it and try to apply it because it will help you to check the various weights.
Okay, thank you, Dr. Okay, for your nice presentations. Yeah,
Okay.
now.
Thank you so much. Sir, I would request you to give some special remarks regarding the session and the papers which were presented.
I would like to thank, first of all, I would like to thanks to the organizer and especially Dr. Neha Tiwari, who moderated the sessions nicely, and all the presenters in this presentation. So in this session, we have presented 6 papers from Yasmin, Marias, Nicole, Paula, Morislav, and Dr. Oki. And you know, all the presenters, including Paula, Morislav, they presented about the latest technology, big data technology, and blockchain technologies. And these are the emerging technology we need to do something for future work. So the problem is in these days, of course, there is a security. And Dr. Morislav presented about the blockchain technology that can solve the security issues, not in the finance sector, but can be used in the various sectors, including the medical, including the transportation, and smart cities and other applications. So now blockchain can be used in various places and various applications. Big data, as per Paula, big data is also a problem, and we need to solve the big data problem with artificial intelligence, machine learning. And we are also working the edge computing because you need to solve the problem at the edge. So the future emerging technologies are the big data technology, machine learning technology. Of course, it's a subset of artificial intelligence, blockchain technology for the security. So these we need to do something. We need to find the way using the future research in these areas. We are also working in the blockchain technology as well as the edge computing part. One of my PhD students is working and to develop the blockchain technology for healthcare system. So I would like to thank all the presenters, all the authors again for their valuable time, nice presentations, and I think the outcome of these presentations will give the future direction in the science, technology, engineering, and mathematics. As per Paula, science and technology are very important, but I will add another 2-term STEAM, science, technology, engineering, mathematics. We need to do some work. Thank you, Dr. Neha.
Prof, can you leave your address for us?
Say again, doctor.
Can you leave your email address for us at the chat?
Okay. I'm professor in NUST. I'm your neighbor, doctor.
Thank you so much, sir, for comprehending the session in such a wonderful manner. I sincerely thank our authors for their extremely excellent presentations in this session and all our participants for being a part of this international conference. I hope this session was informative one and provided a good platform to exchange our knowledge. All the presenters will be getting their digital certificates through email within 2 working days. Further, all papers have already forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of ICICT 2022. I also extend a warm thanks to our session chair, Professor Dharam Singh Jat, for chairing the session. Just as a token of appreciation to the chair on behalf of Team ICICT 2022 and Global Research Foundation, we are displaying this Session Chair Certificate of Appreciation. Thank you for your valuable presence. I request everyone to turn their cameras on for a while so that we can capture this lovely moment for a lifetime. So can we have those wonderful, lovely smiles on our faces along with the camera settings? I think they have been turned on by everyone. So let's turn on the smiles on our face as well and capture this moment together till we meet again. Good to see such lovely, smiling, cheerful faces. Thank you so much, everyone. It was wonderful
Thank you.
to meet you all. Thank you. Okay,
Neha,
so yes, yes, sir.
Dr. Neha, I'm supposed to chair another section. Is it on now or is still? When is the session 3B started?
3E or 3B?
3B.
Okay,
You don't
so it
know.
will start at 10. All right. So as per IST, it will start at 10:15 p.m. But as per your time, I'll just let you know. Give me a moment.
How many minutes
All right.
more?
So it will be 4:45 p.m. for you.
Yeah, that will be 6:45 for me. Okay.
Okay, all right. That's altogether different because we are having
We are
people
2
from
hours
different
ahead. We are
time
2
zones.
hours
I know,
ahead.
right?
To be 6:45. Okay.
Thank you
All
so
right.
much,
Thank you.
everyone. Take care.
Okay. Mm.
Stay safe.
Okay. Thank you.
Thank you,
That's much
for the
required.
presentation.
Thank you.
Bye.
Pleasure is all, sir.
Bye.
So we are ending the session now. Thanks once again.
Okay.